I will now begin the first part of the intermediate course on the fundamentals of noise. The intermediate course consists of two parts, the first of which explains the characteristics and attenuation properties of EMI/EMC filters. First, I will explain the characteristics and configuration of EMI/EMC filters, which are noise suppression components. The EMI/EMC filter acts like a wave dissipating block. Rough waves, representing noise in the open sea, pass through the wave dissipating block, which acts as an EMI/EMC filter. This reduces the wave height, that is, the noise level, so that the connected equipment in the cove is only exposed to a much smaller amount of noise. The ability of this wave dissipating blocks is the attenuation properties of the EMI/EMC filter. This section describes a circuit for measuring the attenuation properties of an EMI/EMC filter that reduces noise. There are two types of EMI/EMC filter attenuation properties, differential mode and common mode, and the attenuation properties are measured using different connection methods. The attenuation was measured at different frequencies, and the attenuation properties are shown in this graph. I'd now like to explain the circuit configuration of the EMI/EMC filter. The circuit configuration of the EMI/EMC filter includes a one-stage filter and a two-stage filter. A one-stage filter with one choke is called a one-stage filter, and a two-stage filter with two chokes is called a two-stage filter. A two-stage filter has better attenuation properties than a one-stage filter, but a two-stage filter costs more than a one-stage filter because it requires two circuits. I will explain the characteristics of attenuation properties according to the different parts used. Common mode attenuation properties can be improved by changing the core material used in the choke. The core material of EMI/EMC filter is usually ferrite. Changing the core material to a nanocrystalline amorphous material with high impedance properties can improve attenuation properties, but nanocrystalline amorphous material is expensive, resulting in higher costs. In this section, I will describe the characteristics of attenuation properties according to the line-to-ground capacitor. Common mode attenuation can be improved by increasing the capacitance of the EMI/EMC filter's line-to-ground capacitor. However, it should be noted that increasing the line-to-ground capacitor capacity also increases the leakage current. Leakage current may be regulated depending on the application. In particular, medical equipment and vending machines have stricter leakage current limits than other equipment. Moreover, if the line-to-ground capacitor capacity is increased, the leakage current will also increase, possibly resulting in non-compliance with cutoff current requirements in the pressure test at the time of shipment. Careful attention should be paid to attenuation properties and leakage currents when changing the selection of line-to-ground capacitors. Lastly, let's look at an example of conducted noise voltage countermeasures that achieve low leakage current. If the noise source is a switch mode power supply, select a low leakage current product as the switch mode power supply. Although a switch mode power supply with low leakage current increases conducted noise voltage, this noise can be counteracted by adjusting the leakage current to the optimum level for the device with an EMI/EMC filter. By selecting the capacitors to be installed in the EMI/EMC filter, both low leakage current and noise suppression can be achieved in the entire system. This concludes the first part of the intermediate course on the fundamentals of noise. Thank you for watching. Please now watch the second part of the intermediate course on the fundamentals of noise.